Hello everyone. Welcome back to my channel. Today we're going to tackle a medium-level problem on LeetCode. Create a binary tree from descriptions. This problem is really cool because it tests your ability to think about the structure of a binary tree and how you can reconstruct it from a set of descriptions. So, let's dive right in and see how we can solve this problem. The problem gives us a set of descriptions where each description is a vector of 3 integers. The first integer represents the parent node. The second integer represents the child node. And the third integer is a boolean that tells us whether the child node is the left child or the right child of the parent node. Our goal is to construct a binary tree from these descriptions and return the root of the tree. To understand how we can construct a binary tree from these descriptions, let's think about the structure of a binary tree. A binary tree is made up of nodes, where each node has a value and 2 children, a left child and a right child. When we're given a description, we can use it to create a node for the parent and a node for the child. And then we can assign the child node to the left or right of the parent node based on the description. This process is kind of like building a house, where we start with the foundation, which is the parent node, and then we add the walls and the roof, which are the child nodes. So, let's think about how we can use this intuition to construct a binary tree from the descriptions. The first step is to create a map of nodes, where each key is the node's value and the value is the node itself. This map will allow us to keep track of all the nodes we've created so far. Then, we can iterate through the descriptions, creating nodes for parents and children if they don't exist, and assigning left and right children to their respective parents based on the description. Finally, we need to find the root node of the tree, which is the node that is not a child of any other node. This is kind of like finding the foundation of the house, the node that everything else is built on top of. Now, let's take a look at the code. We start by defining a class called solution, which has a method called createBinaryTree. This method takes a vector of descriptions as input and returns the root node of the constructed binary tree. The first thing we do is create an unordered map called nodes, where each key is the node's value and the value is the node itself. Then, we iterate through the descriptions. And for each description, we create nodes for the parent and the child. If they don't exist, we use the description to assign the child node to the left or right of the parent node. After that, we create an unordered set called children, which stores all the child nodes. We use this set to find the root node of the tree, which is the node that is not a child of any other node. Finally, we return the root node of the constructed binary tree. Let's go through the code line by line. We start with the for loop, which iterates through the descriptions. For each description, we create nodes for the parent and the child if they don't exist. And then we assign the child node to the left or right of the parent node based on the description. Then, we create the set of children and find the root node by iterating through the nodes and checking if each node is a child of any other node. The time complexity of this solution is O(n), where n is the number of descriptions. This is because we're doing a constant amount of work for each description. And in the worst case, we have to iterate through all descriptions twice, once to build the tree and once to find the root. The space complexity is also O(n), where n is the number of descriptions. This is because in the worst case, we have to store every node in the map, and the number of nodes will be equal to the number of unique values in the descriptions. That's it for today's problem. I hope you guys understood how we can construct a binary tree from descriptions. If you have any questions or you'd like to see more problems like this, please let me know in the comments. Don't forget to like the video, subscribe, and comment your approach below.